Welcome back everyone to the final part 3 bonus challenge section of the k-means clustering exercise solutions. Here we're going to show you how you could have used the links to install the Plotly library and then create a geographical mapping for your cluster model country code label. So let's head back to the notebook and finish it off. Okay, so here I am at the notebook. It's time for the bonus challenge. Recall that previously I already have my cluster labels here as model.labels and as this column within the X array. So I can come back down here to the bonus challenge, see how we're going to do this. Well, the first thing is we had to figure out how to install the Plotly library. I have this link on getting started. It's actually super easy. You can just do a pip install. So there's a lot of different instructions here on different ways you can install it, but probably easiest is to either use pip install or const install, or if you really want to, inside the Jupyter Notebook yourself, you can say !pip install Plotly, run that, and it may take a few minutes, but it should actually be able to install it directly from your Jupyter Notebook. I already have it installed, so we're going to skip that step and move on to step 2, which was to figure out how to create a geographical choropleth map using Plotly. If you click on this link, pretty much all you need to know is at this link. If you go to choroplethmaps.plotly and begin to scroll around here, we see the using built-in country and state geometries, and this is exactly what we're looking for here. Notice that it's showing life expectancy. What we're going to want to do is color map these countries based off the clusters they belong to. So again, kind of a creative way of clustering countries and using unsupervised learning. So what do we actually have to figure out? Well, we essentially need to figure out how to use this code. And pretty much all of it's there. You can see they're using df as the data frame values for life expectancy, but what we want to do is use our data frame and have the color aspect be equal to not life expectancy, but instead that k is equal to 3 cluster label. So we can just easily copy and paste this. So I'm going to say copy, come back up here, and what we're also going to do is figure out the ISO codes. So that's kind of step 2 in this, but I'll scroll down here and let's check this out. So if I copy and paste this, I have import plotly.express as px. That's looking good. df, I'm going to delete this since we already have our own data frame. So we can pass in, instead of df, I could pass in x as well, depending on exactly how we wanted to map this. So we'll see right now in a second how we're going to do it. And what I also need to realize is I need to change the color, maybe change the hover name, color continuous scale. I don't need to worry about that. So we're going to start deleting this. And there's really just 3 things I need to take care of, which are my locations, color, and hover name. So what we need to realize here is I need ISO location codes. And we actually already provided that for you. We have country ISO codes. So what is this? Well, if you take a look at this mapping, what's happening here is if you hover over United States, notice it says ISO alpha is USA. And ISO alpha for Canada is CAN, and maybe ISO for alpha for Spain is ESP or España. And you can see that there's essentially unique 3-letter codes for every country on the planet, and this is actually standardized, which is what this CSV file is going to show you. So we're going to come back down here and actually open this up. We're going to say right here, ISO codes is equal to PD read CSV. Read underscore CSV. And then here underneath the data folder, we've provided you with the country ISO codes.csv. Okay, so once we've read in ISO codes here, we have the country column, Afghanistan, and then that unique ISO code AFG. And recall, our original data frame, DF, has that country name, Afghanistan. So what we need to do is create a new column based off the mapping of ISO codes to this country. What's the easiest way to do that? Well, probably the easiest way to do it is to use something like PD merge, but then PD merge has the issue of the fact that we did drop some countries before running k-means clustering. So what might be even easier in that is to just reformat ISO codes to be a dictionary mapping. And you can do that by saying ISO codes set the index to country. So note that gives you something that looks like this. And then I can just grab the ISO code column off of that to get what is essentially a series and then move this to be a dictionary. So I can say to dictionary. This is why it's kind of a bonus challenge, because there's a lot to go on here. And now I have a direct mapping of the country name to the 3-letter ISO code. So I'm going to say ISO map is equal ISO code's set index. And what I can then do is say df ISO code is equal to df country, whoops, forgot df here, df country, and then go ahead and map ISO map. So now if I take a look at my data frame, I now have the country column, and if I scroll all the way to the right here, I can see I now have that correct ISO code. Notice for some of them it didn't match up, but that's going to be okay for us. So what we're going to do here now is see if we can plot this out by passing in df here. And what I want to do is edit one last thing to add in the cluster itself, and that's going to be equal to model labels underscore. Run that, and now my data frame, if I take a look at it again, has the country name, the ISO code, so I'm going to scroll down here, or scroll to the right really, and the cluster assignment label itself. And I chose k is equal to 3. You can experiment with whatever k value you want. All right, so if we take a look at what we need to swap out now, locations is not a column called ISO alpha. It's actually the column ISO code. Color, we want to color it based off the cluster column, not some life expectancy column. So we'll say cluster here, and the hover name, we want to show the country. In our case, it's country column for capital C. So these are just, if you take a look at the Plotly documentation, they're just Pandas column names. And one needs to match up to the ISO code locations, one needs to match up to the color-based system you want to choose, what do you want to color based off of, and then you have the hover name. So when you run this fig show, hopefully in a little bit we will see now the coloring for our countries. And there you have it. These were the countries that were done completely unsupervised based off just the features of the countries itself if you were to set k is equal to 3. And there's a very strong relationship here of kind of more modern, well, maybe modern is not the right word, but let's say Western European style countries like Australia, Japan, Western Europe, United States, and Canada, then another subset of countries, and then South Africa, or really kind of everything in the Sahara, and then south of that in Africa. So this is just completely unsupervised, and it's kind of amazing that just based off the feature sets, we were able to kind of distinguish 3 main categories. And what you can do is begin to expand the number of clusters you allow to really begin to explore how we could even separate out these countries into further groupings. Okay, hope you enjoyed that challenge. There's still a lot you can discover here and play around with. I would highly encourage you to check out that Plotly documentation for more tools and tips. Thanks, and I'll see you at the next lecture.